Can I sit in front of myself? Can I sit anywhere but in my assigned seat? Can I like go over there? Why is this video so long? Can we turn it off? Can we do something else? Can we have free time? Can we go outside? Can we play on Chromebooks? Can we do anything besides this? No. Now that we're clear on what we're not going to do, let's move on. I think this makes my face look cute.
So our next review sheet is the coordinate plane. And so a lot of you, this is going to be just that. It's a review. We learned a lot of this stuff in elementary school. We have not gotten to the section where we really focus on it in sixth grade, but just a couple of facts about the coordinate plane. So the coordinate plane runs on two axes, and those two axes are the x and the y axis. And so our x-axis is our horizontal axis, so labeled that on the horizontal, and then our vertical axis is our y-axis. And part of the way that I distinguish between the two is that the y-axis goes straight up and down, kind of like if you made a capital Y like that. So that's my vertical axis. All right, so the big thing that we learn about is in the coordinate plane in sixth grade are the different quadrants. So identifying how do I know where a point falls, and in this case, these are considered the four quadrants of my coordinate plane. So you don't have to circle those. I'm just showing you on my screen that those are the four quadrants. And we actually label them going in counterclockwise order. So quadrant number one, I'm going to make my pen just bigger on this one. Quadrant number one, we use a Roman numeral 1, which looks like a capital letter I. That's our first quadrant. And in our first quadrant, both values for x and y are going to be positive and positive. And then in quadrant number 2, again, we're going to go counterclockwise. Quadrant number 2 is going to have a negative x value because we go back on the negative x value, but then we have to go up to plot the second point. So that's a positive for the y value. So negative and positive. And just based on those signs, you can kind of mentally track those signs as to whether or not you're going to the left or to the right or up or down to figure out what quadrant you're in if you're asked that question. The next one is our third quadrant. So we make 3 lines and connect them up at the top. That's our third quadrant. And these are actually both negative. You go to the left and you go down to plot the point for that one. Our last one is our fourth quadrant. That's signified with a line and then a V. And our x value is positive because it goes to the right, and then our y value is going to be negative because it goes down. And so we always begin at the origin. So put a dot right there and draw an arrow that says origin. The origin is where we always start from, and then we go locate to the x coordinate by moving horizontally. So we either go to the left or right, depending on the sign, so whether it's positive or negative. And then the y coordinate is going up or down. All right, for reflections. So reflections are when we actually do a mirror image across a certain axis. And so the way we do that is we make sure that first we identify what are our axes. We've got our x and our y, and then we identify where our original point is. And our original point is always the letter that's just by itself. So in this case, A is my original point, and it's actually going to be 1, 2, 3, 4 units to the x-axis, and then A prime is 1, 2, 3, 4, 5 units on the opposite side, and that is actually an error. So that's actually really funny that we identified that. So we're going to actually cross this out, and I want you to put A prime up a spot, because a reflection by definition is the same distance away from the axis as its reflection is on the opposite side of the axis. So if A is reflected across the x-axis to A prime, we also have to go 4 units down away from the x-axis on the opposite side, so from quadrant 2 to quadrant 3. And so again, let's see that one more time. I'll use a different pen to reiterate that. The reason we had to cross it out and change it is because 1, 2, 3, 4 units to the x-axis. This is like my mirror. I have to go 1, 2, 3, 4 units on the opposite side of that. And so this paper actually had it plotted 1.2 far down. The next one is my B to B prime. My B to B prime, if I head towards B prime, it's 1 jump until I get to the y-axis. So B is reflected across the y-axis in this case, and then B prime is 1 unit on the other side. So B to B prime. So that's all a reflection is. So let's do one of our own. So I'm going to switch again to a different color. So if I plot C at 3, 3, that means that I have to decide, am I going to reflect it across the x-axis or am I going to reflect it across the y-axis? Let's go ahead and use the x-axis. So I'm going to go down to the x-axis. It takes 1, 2, 3 units to that x-axis. And if I want to reflect it across the x, I have to do 1, 2, 3 units on the other side, and that's where my C prime would be. All right. For polygons, it may ask you to identify the points that make up a polygon or to create a polygon on a coordinate plane. And one of the most common polygons that you can make on the coordinate plane pretty easily is a rectangle. And the reason it's so easy is because you just need to choose 2 points to connect. And after you choose those 2 points, you choose whatever the distance of the side is, so the width of the polygon or the width of the rectangle. And then we have to make sure that we have a parallel side that's directly across from, in this case, AD. We need to make BC parallel across that horizontal line. And then we also connect it with the other side. And so creating a rectangle or a square of some kind usually tends to be the easiest. Remember that a square has all equal sides, so that you would have to be more diligent about the sides. But identifying these points, remember we always start at the origin. And so we go to the left or right first. So I'm going to go -1, -2, -3. So my first part of my first ordered pair is -3. And this is like telling me directions of how to get to A. And then +2. I went up 2 units. Then for B, I'm going to start at the origin again. And I'm going to go over 1, 2, 3. That's -3 because I went to the left. And then I'm going to go down 1, 2, 3. And that's also -3 because I said I went down 3 units. All right. If you notice, they both share a -3 in the x coordinate because they are across from each other. So that's pretty cool to see the correspondence in those ordered pairs. For letter C, we're going to start at that origin. We go over 1 unit. That's +1 to the right. And then we have to go down 1, 2, 3. So down to -3. And again, we see that C and B share a y value because they're straight across from each other. Our last one, because it's straight across from C, we know that it's going to go over 1 unit and then up to don't put a negative, up +1, 2 units. Okay, so those ordered pairs, they're like directions. They tell us how far do I travel left or right, and then how far do I travel up or down to get to my location. So that's just a quick overview of the coordinate plane. Now you can go on to practicing. Okay, for our next part of this, we're going to actually practice doing this by doing lesson 13. And this lesson 13 is from our next books that we're going to be using. And so we don't actually have number 13 ready to go. And so that's why you're getting a printed version of this lesson because it's not in the current books that you have. So on this, follow along, and we're going to be talking about how to identify unlabeled points and to label them, as well as how do we interpret points on a graph by looking at what are the labels and what are the expectations for answering different questions with it. So looking at this first section, we're going to talk about unlabeled points. So when we have an X and a Y coordinate plane, we look at this and there are situations where we actually have to label the different points. And so down below, we have different points that we're going to find. So we've got A, B, C, and D. So those 3 points are the ones that we're going to be looking for on our graph. The easiest way to do this is to actually start at the origin yourself. So right here at the middle, remember that I'm going to mark this up some and then I'm going to undo it just so that I call attention on your screen to what you're looking at. But we are going to start at that central point, that origin, and we are actually going to graph these ourselves because that's what makes it easiest for us to label unlabeled points. And my first one down here, A, is 7, which means I go in the positive direction. So I'm going to actually mark this up. Usually we don't actually mark up. We don't highlight this or anything, but just so that you can see it on my screen better, I'm going to highlight what I'm doing. So I'm actually going over 7 units. And then I look at the second one and negative 5.5. Now, I can look up and there's no points there. So I know that it's got to be down here. This is the only one that's in the correct direction, 7 units to the right. And then negative 5.5 means I go down to negative 5 and then I go an additional half of a unit. And that's where my A is. So you're not highlighting like I am, but you're just going to put the letter A next to that coordinate. The next one that we have is negative 8.4. So B is negative 8.4. So negative 8 implies that I'm going to go to the left 8 units, so to negative 8. And then I'm going to go up positive 4. And that's my B. So I'm going to label my B right there. Then for letter C, we're going to go over positive 3 and then up 2. And you see we are running into these points because these coordinates are telling us what directions to go. And that's what I love about the coordinate plane is that it's so precise and it tells you exactly where to go left, where to go right, where to go up, where to go down, all using those positives and negatives. The last one, D, is process of elimination. The last one has to be the only one that's remaining on the graph, but let's just double check that. Negative 3.5 means the negative is 3 units to the left and then an extra half unit. And then 2/10 is just barely above the 0. So it's just barely above that x-axis line, 2/10 of a whole. So that's my letter D. If you have different strategies to do that, that's fine, but that's the one that I always go to is just plotting the points myself by following using my pencil, just like I showed you with the highlighter. I was actually using my Apple Pencil to follow it, and I just follow the grid and find my correct points. Now, the reason it's so important you understand how to graph these points is because you need to be able to identify what do these points actually mean. So let's take a look at it in a real world context of how we could plot points on a graph that actually means something. And a big thing is account balances. So money. It says the graph shows, and that's a key thing right there on the state test and on different tests that you take, like the NWEA. If it says that the graph shows it, it means you're going to need to interpret the graph and read it, and you have to be able to know how to read those different parts. It says the graph shows the balance in a bank account over a period of 14 days. The axis labeled B represents the account balance in dollars. The axis labeled D represents the day. So just like always, I'm going to go through and underline and highlight key information in that because I want to make sure that I understand what the graph is saying. So I already highlighted the graph shows because that's important to me. It shows the balance in a bank account. So the balance in a bank account is what it shows, and that's over a period of 14 days. So again, I always like to circle my numbers and underline the key details. The second part says the axis labeled B. So labeled B means it's equal to the account balance in dollars. So right there, we're talking about money. So when I look over here, the axis that's labeled B, which is considered my y-axis, the reason they labeled it B in this situation is because it represents the balance. This is just my money account, or that's my money. So if the dot is in line with that axis, that's how much money is my account. And yes, you can have negative money. We're going to talk about that. So then D is my other one. That's actually my x-axis that we're used to. But the reason they call it D is because it's for the days. So the days are the numbers 1 through 14 that are growing across that x-axis. So if you look at it, it says the second part we just said was it represents how many days it's been. And so now we're going to talk about how do we interpret this. So when I'm looking at this graph, if I look at it, as I go across the x-axis, I'm actually looking at the number of days. So this would be day 0, however much money I have in day 0. They didn't put anything in. They don't represent anything as day 0. They represent it as day 1. So they're saying that on day 1, there was, if I follow it up to the dot and I track it over, $350 in the account. On day 2, you see that the dot is still in line with 350. That means that no change took place. So that's no change. And then you say on day 3, again, that's no change. So there we have those 3 days that there was no change, and you can see it just goes straight across. Then on day 4, something happens. If you notice, it's lower. So that means that I had a drop in my account, which means I took money out of my account. And how much money did I take? Well, if I track it over, we have to estimate this because we have to see that this is right in the middle of 250 and 300. Right in the middle of 250 and 300 is 275 because 50 divided by 2 is 25. And so we add that 25 onto the 250 to get the 275. So we did have a drop in money. And then for day 5, we ended up with, it stayed the same. Again, we move on and we get to day 6. Now, here's where it gets a little bit crazy because in day 6, we had a massive drop. Our balance ended up below 0. And yes, that can happen. It's called overdrawing your bank account. It's overdrafting. And if you overdraft, it means you spend more money than you actually have. So in this case, not only did they spend all $275 that they did have, so that's that drop, the $275 to 0, but they also spent an additional $50 that they did not have. So in that change there, we drop all the way down below 0. After that, day 7, we see that it pops back up. So on day 7, our bank account balance goes back up into the positive, just above 100. I would say that was maybe like not exactly 125, so maybe 115. Again, this is like an estimate. If we don't have the precise measurements and everything, we just have to estimate it if it's not labeled properly. And then day 8, 9, and 10, you can see that they all stay the same. So it looks like they deposited money. They went back up. They deposited money into their bank account. Maybe they got paid at work. And for 4 days, they didn't spend anything. And that was probably good because if you drop down below 0, that's not a positive thing. And so that's how that goes. So then on day 11, again, they overspent their account. So maybe they had something that they had to pay for. And so their balance dropped the $115 to 0, but then they spent just below $100 more. So it's just below that negative $100 range, which means that not only did they spend $115, but they almost spent another $100. So we're talking, probably pushing $200 that they spent that they probably shouldn't have. And then again, day 12, they deposit a little bit of money. It goes back up. We have a deposit into the bank account on day 12. And day 13, it stays the same. And then on the last day, that's probably when they got paid. Their paycheck went all the way up and deposited in their bank account. And on day 14, their amount in their account, and again, we have to follow it all the way over, me and my squiggly line, $375. So they deposited a good chunk of change into it. Now, when you're asked questions about these, you have to understand what numbers are you subtracting and adding, and what do you have to do to find the changes that are taking place. It says in the first one, estimate the greatest account balance. So the greatest account balance, okay? So the most money. What day was the most money? Well, the most is always going to be a positive, so I know that I'm going to be looking at this part of the graph, and then I'm going to be looking for the highest dot. So the highest dot here is right there at the top. It's right in the middle of 350 and 400. So that is $375 on, and it says on what day? That's the question. So $375 is not the answer. The answer is actually $375 on which day? That was day 14. Okay, the next one says estimate the least account balance. So the least money in the account. So we're looking for the lowest. It says on which day did that occur? So again, it doesn't matter how much, it just is the lowest one, and we're looking for the day. So the lowest dot on this axis here, the lowest dot is in the negatives, and that lowest dot is right there. And so it looks like it's about -90 or -80. But again, the question is, what day did it occur? And so we have to pop back up to our axis that says our days. Our D-axis is on day 11. And I would say, just to do some extra practice, about $85 on -$85 on day 11. So the negative is really key there, because the lowest amount could be 0, but it could go below 0. And when we go below 0, that's when we use that negative symbol to indicate that. What does the 0.6 -50 tell you about the account? So when I'm trying to interpret a graph, I just have to check the labels. So I plot the point. So if I go across to 6, what does 6 actually mean? I'm going to change this over to red so you can see me track this. I'm going over to 6. 6 is the amount that I'm talking about. And then I go over to my axis. What axis is this? It's the days. So 6 means on day 6, the account had, and that -50, when we drop to that -50 mark, that's on the money axis. So -50 means -$50 in the account had -$50. Sorry, I didn't realize I'd already put a count. So that -50, we're looking at where it lines up with on the axis, and that axis tells me that it's the dollars, the account balance. How can we interpret -50 in the context of the situation? So the absolute value. So these lines right here means the absolute value, the distance. Okay. And the distance for this is that we are $50 in debt. Okay, so instead of saying negative, the absolute value is a distance from 0. That's always going to be a positive. So to describe what it means in the context of this situation is that 50 units from 0 in the negative direction means that we're in debt, and you don't want to be in debt. You want to have the money in the bank. So that's what that distance from 0 means. We can also apply this to high and low temperatures. And so just plotting the points of temperatures, a lot of you have probably seen on the TV when they show you graphs like this, a lot of times they will do, so like for instance, the high, red means high, okay? And so a lot of times on the news and stuff, they will actually connect the graph like this, so you can see how the temperature changes. That's how they do it on the TV, so that you can see that. They also usually take like the low temperatures, and they will connect the low temperatures in like a blue color, because blue means cold. And so they show you the difference of the highest temperatures versus the lowest temperatures, and they actually kind of move together, because the higher the high is for the day, usually the low temperature for the day is going to be pretty close to it. We don't have huge swings unless you live in Michigan, and then it's always cold and it's miserable. So for this one, it says the coordinate plane shows the high and low temperatures in Nome, Alaska over a period of 8 days. The axis labeled T represents temperatures in degrees Fahrenheit. The axis labeled D represents the day. So when I look at T, that means T represents the temperature in Fahrenheit. So we're going to put degrees, switch over to my pen, degrees Fahrenheit. So that's telling me that that's the temperature. And I label that just so that I can see clearly what that axis talks about. So 2, 4, 6, 8, all these numbers here, if it's in line with that number, it's talking about the temperature that it is. Then on the the other axis, the axis labeled D, that represents the day that we're tracking this. And again, we tracked it in Alaska over 8 days. So this is days that we're tracking it. So we see days 1 through 8 on there. They even have a 9 on there, but we didn't track it that day. So let's try and answer some questions about this. What was the warmest high temperature? So again, we've got our labels here that say that the dark triangles are the high amount. So we want to look for the warmest, which means the highest on the graph. So the warmest high temperature. So that means that I'm specifically looking at the high dark triangles, and I'm going to look for the warmest, which means the highest on the graph, and that would be this first one. That first one is on the very first day. And what temperature is that? Well, this is day 1. That doesn't mean 1 degree, it means day 1. And if I look to the temperature axis, it's in line with 28 degrees Fahrenheit. It then says write an inequality to describe the high temperatures over the 8-day period. So to write an inequality for this, the temperature is what I'm focused on. The temperature was always less than or equal to 28 degrees Fahrenheit. And then the lowest high temperature was 2 degrees. So it was always, the temperature was always greater than or equal to 2 degrees Fahrenheit. So this is an inequality that has constraints on both sides. The highest temperature that it could have been was 28 degrees, and then the lowest temperature was 2, and you've got the temperatures in the middle of that. But we also have to include the greater than or equal to, so that line underneath, we have to include that in our inequality, because one of the days was 28 degrees and one of the days was 2 degrees. Okay, the next one asks us about what's the coldest temperature. So our low temperatures are probably going to have our lowest temperature. And so if we look at this, we're trying to find the one that is the lowest in line on the temperature grid, on the temperature axis. So if I do that, the lowest one that dips down is this temperature, and it looks like it's right in the middle of -3 and -4, which means -2 and -4, which is -3 degrees Fahrenheit. And then for our inequality to describe the low temperatures, L over 8 days, we're going to put the temperature for the low temperatures, L, low temperatures. Oh, you know what? I used T for temperature. They wanted us to use H. Always pay attention to what variable they're asking you to use. So then for this one, L. Okay, the lowest temperature, again, the lowest temperature is going to be less than or equal to whatever that highest low was, which was 26 degrees Fahrenheit. And then if we look, so there's the 26 degrees Fahrenheit, the lowest of the low, which is the lowest the constraint can go, the lowest temperature was equal to or greater than -3 degrees Fahrenheit. So we've got those constraints on both ends. The temperatures have to be lower than 26, but they have to be higher than -3 or exactly those two numbers. That's why we put, again, that equal to symbol on the bottom of that. On which days did the largest difference between the high and low temperatures occur? Write this difference down. So between the high and low. So we're looking for the high and the low. Okay, so these two are the high and the low for the day. These two are the high and the low. We want to know which one has the biggest difference. So to do this, you kind of have to eyeball it at first, and it's kind of tricky. You got to count the spaces in between. I know that these two over here are not going to be it. These two, I can kind of eliminate these ones. Those ones all don't have big differences. I can see this one isn't, this one isn't. And then these three are kind of, I can even say that this one isn't, but these two, I really got to do the math on it to make sure I'm finding the one that's the biggest difference. So remember that the interval is by 2, so one whole space right there is 2 units. So if I count these spaces, it's 1 unit there, then 2, 3, 4, 5, 6, 7, 8, 9, 10. So a difference of 10 degree Fahrenheit change. This one down here, let's try and count this one. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these both have the same distance. I want to check this one too, just to be safe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'm glad I checked that. We've got a 3-way tie. So it says on which days. So notice the S on that because there might be multiple, and it did turn out. It turned out days 3. This day was, so day 3, day 6, and day, which one's 7? Day 3, 6, and 7 all had the same difference. Okay, then we have to find the smallest one. Now, I say don't mark everything up like I do, because now we've got to go back and find the smallest ones. This one looks like it's got to be the smallest. So if you look at this is 2 units. It's 28 down to 26. So that's 2 units. This one over here is 2 units plus that one is 3. So that one's out. And then this one, it's also 1, 2, 3. So the smallest difference that there was between was day 1. All right, we're gonna go ahead and stop there because